Throughout this course, we're going to be talking about functions, so it's a good idea to know what a function is and how to recognize one. Any collection of ordered pairs like we have here, 3, 2, 5, 4, 7, 6, 9, 8, etc. Any collection of ordered pairs like that is called a relation. But a function is a special kind of relation, one where we say each input has a unique output. So each input has just one output. And this is a function because each input has one specific output, right? The input being x, the output being y. So an input of 3 has an output of 2, input of 5 has an output of 4, etc. This is not a function because we have inputs 1, 5, 2, 10, 4, 15. That's okay. But when we get to here, we have a second output for 2. So if we were to say, what is the output for 2, we wouldn't know if it was 10 or 20. The output for 1, we wouldn't know if it was 5 or 25. And that's not a good situation to have where you don't know what the output for a specific input is. So we don't want that when we're talking about functions. Okay, so functions are really easy to recognize, or non-functions are really easy to recognize too. If you have a repetition in your inputs with different numbers in the outputs, that's not a function. This one here would be the closest thing I could think of to a trick question. I don't like to ask trick questions, but this would be it if I was going to, where I've got a lot of repetition in the outputs. But that's okay because each input still has its own output. Each input has a unique output. I know the output for 2 is 3. The output for 6 also happens to be 3. The output for 8 is 5. There's no question there. Okay, so when you're looking at functions in this form, in tabular or table form, where you've got a list of inputs and outputs, if there's no repetition on the x's, on the inputs, you're good to go, it's a function. If you have repetition in the x's, it's not a function. Now what if you're looking at the graph of a function? These here, 3, 2, 5, 4, 7, 6, and 9, 8 are these points I've graphed here. I haven't bothered labeling them. And we've seen functions already that look like this, right? These all fall right on a line, and that's a nice function. The points from here, yes, 1, 5, 2, 10, 1, 5, 2, 10, 4, 15, 2, 20, and 1, 25. Remember, this is not a function, and the thing that stops it from being a function is where we have 2 different outputs for the same input. And what that translates to visually is if we look at the input of 1, we have 2 different outputs there. And that's 2 points that are vertically related, right? They have the same x coordinate, the same input with 2 different y coordinates, 2 different outputs, and that's the situation we need to avoid. So if you've got a graph and it has 2 points or more that are vertically related like this with the same x coordinate and different y coordinates, that's not a function. Now we have a test for this. We call it the vertical line test. If it's possible to draw a vertical line that hits the graph at more than 1 point, boom, I can hit it at those 2 points there, then that's not a function. That's all there is to the vertical line test. So if I've got a function that looks, say, clear up some space here. If I've got a function, get my axes there, that looks like this. I can draw a bunch of vertical lines, but any one vertical line is only going to hit that graph at 1 point. So that is a function. If I've got a graph that looks like this, well, I can draw a vertical line that hits that at 2 points, not a function. If I've got a graph that looks like this here, I can draw a vertical line that hits it at 1, 2, 3 points, not a function. Very simple test. That's all there is to identifying functions.